Our mathematician of the day is a famous one, Leonhard Euler. He was a Swiss mathematician, and his father trained him to be a pastor, but he loved math even more. The bridges of Königsberg is a famous problem that a lot of students are confronted with. What they wanted to do is the city wanted a parade route, and they wanted to make sure that they could go over every single bridge without crossing over another one. But Euler proved it couldn't be done without going over at least one bridge twice. Another thing that Euler discovered was a formula for giving the relationship between the number of faces, vertices, and edges for polyhedrons. So let's first of all take a look at the difference between a vertex, a face, and an edge. So if you have a cube, when you look at one side of it, that flat surface is the face. The vertex is where two of the edges come together. The edge is the straight line between the vertexes. What Euler did is he came up with a formula to discover the difference and the relationship between all of those. So if we have a cube, which we have right here, we can see the number of faces. There are 6 faces to a cube. The vertices are 8. The edges, so there's 1, 2, 3, 4. If you have all of these edges and you go all the way around it, you're going to have 12. So we can see that the numbers are 6, 8, and 12. A square pyramid. The faces, we know that there is a square base, so that is one face. But if there are 4 edges, that means there are 4 more faces coming up, so there are going to be 5 faces. So now this one kind of similar to the one above that because we've got 2 numbers that are the same, and then the next one increases. This one increased by 2, but this one increased by 3. All right, let's try one more. Triangular prism, you're going to have 9. So now there's no pattern to any of these. But what Euler did is he found a relationship between the faces, the vertices, and the edges. So what he did is he took the faces, added the vertices, then he subtracted 2 to get the edges. So now let's take a look and see if this indeed does work. So the faces plus the vertices, 6 plus 8 is 14, minus the 2 is 12. That works. Let's go to the next one. 4 plus 4 is 8, minus 2 is 6. 5 and 5 is 10, minus 2 is 8. 5 and 6 is 11, minus 2 is 9. A lot of different things you can do this with. A lot of different activities here. You can take a look at some of these other ones, try it out for yourself. That's one of Euler's formulas, and that is today's Mathematician.